Hello everyone, I'm Ebiagunza Jeremiah Ugimbana. I'm going to present my poster titled as A Smart Feeding System for Premature Infants. In introduction, the Smart Feeding System for Premature Infants is an AI-driven closed-loop solution designed to address critical challenges in neonatal nutrition. This system will ensure optimal nutrient delivery while reducing complications like reflux and aspiration by integrating non-invasive sensors, real-time data analytics, and precision feeding mechanisms, targeting low-resource hospitals. It aims to improve survival rates, reduce healthcare costs, and empower caregivers with actionable insights. Looking in current technology. In most Tanzanian hospitals, feeding is done through nasogastric or gastric systems. This approach is associated with risks of infection, reflux, aspiration, and discomfort. In high-resource settings, feeding bottles such as Dr. Brown's infant bottle are used, but these are expensive and limited in function as they lack integration with real-time monitoring. The figures below shows some different feeding systems. A. This is the nasogastric tube feeding system. B. This is Dr. Brown's infant bottle. And C. This is the traditional feeding system. Looking to the current progress of this project, we can see these figures here. This is the figure of the whole system, how it will be connected and how it is going to be operating. And this is the figure of the printed circuit board, PCB, of the system, where I will connect all the components of this system. And this is the diagram of the dashboard of the system that will be showing the real-time monitoring of the vital signs and the feeding of the baby and the other data that are necessary of the baby. Looking in clinical rationale, feeding complications are among the leading cause of poor outcomes in neonatal care. A smart, sensor-based feeding solution can help. It will improve safety by preventing aspiration and overfeeding. It will provide real-time monitoring of vital signs and sucking behavior. It will reduce the burden on caregivers by automating feeding control. It will ensure cost effectiveness, making it practical for hospitals in Tanzania and other developing countries. Looking on the need, there is pressing need for a low-cost, safe, and intelligent feeding solution that can be implemented in hospitals with limited resources. Such a system would reduce complications, save healthcare costs, and improve neonatal outcomes. Goal. The goal is to develop, test, and validate a smart feeding system that ensures safe, efficient, and responsive feeding for premature infants, while remaining affordable and accessible in Tanzania and beyond. Looking on the future work of this project, I'm going to develop and test a working prototype in a controlled environment. I'm going to perform system integration, calibration, and refinement of sensors and pump. I'm going to expand dashboard capabilities with AI-based data analysis. I'm going to collaborate with healthcare providers for pilot studies and clinical validation. Also, I'm going to work toward scaling up production for local hospital adoption. Acknowledgement. I would like to express my sincere gratitude to Dr. Delphine Dean, Dr. Lucas, Azrin Jamison, and the Clemson University Bioengineering Department for their guidance and support throughout this project. Special thanks to Dr. Nicodemus Msafiri of Arusha Technical College for his valuable insights and mentorship during the development of this idea. This project reflects a collaborative effort between Clemson University and Arusha Technical College. Thank you.